Greetings everybody. So I just made this video where I just had two objectives really. One was to recognize the equation of a line when you see it, and then the other was that if you needed to graph a line and you had no other way to do it, it would just be a matter of choosing any 2 points on the line, plotting them, and then drawing it. Okay? Alright, so that's what I wanted you to get out of the first video about this. Now I need to talk about something called a linear inequality, okay? And the way I'll bridge that is I'll tell you what a line would look like, and then I'll turn that into an inequality, and I'll show you what would change about it, okay? So let's take this example right here. Say you had y equals 2x plus 1. Hopefully we know from the other video that that is a line because of the form of the equation, okay? Lines look like this, y equals mx plus b. So we could recognize this as a line. If I wanted to graph it, I could plot 2 points. 0 for x and 1 for y satisfy this equation. 2 for x and 5 for y also satisfy this equation. In the other video, when I was making tables, okay, that's all we're trying to do is find an x and y pair that work in the equation. All right, and there's an unlimited number of pairs that will do that. We just need 2 to draw the graph. Okay, so suppose then that here I say that's the graph of the line y equals 2x plus 1. What do you think would be different about it if it was an inequality? Suppose it didn't say y equals 2x plus 1, but it said y is more than 2x plus 1, or y is greater than 2x plus 1. How would we understand that? How would it be different, and so on? Well, so let's think about it like this. So that line, I guess you could say, is all the points x and y where the y is equal to 2x plus 1. The inequality would be all the points x and y where the y is more than 2 times the x plus 1. So here I've highlighted a few points that would be in our graph. So our graph is this dashed line with the shaded portion above it, okay? Like for example, 0 for x and 2 for y. If you put that in here, here's what you're going to see. Say 2 for y, 2 times x, which is 0. So this point right there is 0 for x, 2 for y, plus 1. So is that true? If I take this point, which is in the shaded region of our graph, is the y-coordinate more than 2 times the x-coordinate plus 1? Well, work this out. So is 2 more than, what's 2 times 0 plus 1? It's 1. Is 2 greater than 1? Yes. Okay? All right. So when I present you this graph, all that it would be is some way to indicate where all the points are, where the y is more than 2 times the x plus the 1. Okay? Now that's if you want to think about it philosophically. Then that's what our answer will be. But if you want to think about it in terms of how to get the answer, here's what you do. The line is y equals 2x plus 1. Start with that. That's what this dashed part is. And if y is more than 2x plus 1, does that seem to indicate that the point should be above the line or below it? You know, y on the graph is up and down. If I say y is more, that suggests up. Okay. So yes, that's what you do. If you to draw the graph of y is greater than 2x plus 1, draw the line, y equals 2x plus 1, and then highlight all the points above it. Now what I've tried to do here is shade all the points above the line, okay? And that may or may not look very good to you, but that's what this is, okay? That dashed line is 2x plus 1, and I've shaded all the points above it, and I've even highlighted a few of them that you could plug into this to verify that they work if you want to think about what the answer means, okay? Now, let's talk about some other details of this. Notice that I drew the line dashed, okay? Whereas when I drew this, I drew it solid. Why is that? Well, think about it. That line is all the points where y equals 2x plus 1. This doesn't say equals. This says greater than. So the points on the line are not part of our answer, okay? All right, that's why it's dashed. The fact that it's dashed indicates that, well, I need this line to be there for reference, but it's not part of the answer. Just the points above it are part of the answer. Okay? All right, so that's what a dashed line will be in our problems. Now, if you have a greater than or less than, the line will be dashed. If it was greater than or equal to or more, less than or equal to, it would be solid. Why is that? Well, because the equal to is included. The line is equals. So if you have a or equal to, the line's going to be part of the answer. Okay. All right, so there's my answer to this one. There's the graph, the shaded portion here above that line. Okay. That's my graph of the inequality y is more than 2x plus 1. Okay. What if it was less than? I would have shaded below it. If it was y was less than 2x plus 1, it would be all the points below the line. Okay, so the greater than, y is greater than means above the line, y is less than means below it. Okay, with that in mind, what do you think y is less than or equal to 2x plus 1 would be? So I'd start with drawing the line, 2x plus 1, which is right here. Goes through 0 and 1 right there on the y-axis. Okay, and if this says y is less than, that would suggest that the points below it are actually where the answer is. Okay, so I've shaded all the points. My shading here indicates I want my answer to be all the points below this line. Notice this time the line is not dashed because that's a less than or equal to. So the equal to is the line, the less than is all the points under it, and those together are the answer. Okay, so the graph of this, the points on the line and all the points under the line, you could say. Okay, that's how you graph inequalities. Now, why is that important? Well, I'm working up to doing linear programming. I said that in my other video. And see this, like we got all these inequalities. So we're like below some lines, above others. And then there's this overlap that we're looking at, okay, when we do linear programming. All right, now I'm only mentioning linear programming to say this is where we're going, and I'm trying to show you stuff to get up to this point. All right. Okay, so in graphing linear inequalities, it's really just a matter of graphing a line and then looking at the inequality and figuring out, well, am I looking at the points above the line or below it? Y is greater than means above, y is less than means below. Okay, all right, so let's look at this. So suppose you had a system of inequalities. And what's different about that is, so far, I've only looked at individual inequalities, okay? Meaning that we have these all by themselves, all right? Okay, so say you had like 3x plus y is greater than or equal to 3. You could graph that all by itself. Or x is less than or equal to 3. You could graph that all by itself. So now I want to talk about what points are common to both of these, meaning if you took this graph and this one, what would the overlap be? So real quick, before I get to that, let's say, would this one, I don't really think this is in the right form to graph it. Okay, so, you know, with this, I think it'd be easier to see it this way, or to see like an inequality like this, you know, something like this. Okay. So I'm gonna turn this around. I'm gonna say I want to isolate the y because that's more the form I need to see it. So it'll be, if I move the 3x over, it'll be like this. Okay, so I'll subtract 3x from both sides, and that's more like it. So here's how you would think about the graph of this one, which is the same thing as that. I would draw the line y equals negative 3x plus 3, which is this line right here. Remember, you can plot 2 points on it, and you could draw the line that way. And since that's y is greater than or equal to, I want to include all the points above it. So that's what I've shaded here. Okay. Now, all right, so there's my graph of 3x plus y is greater than or equal to 3. What about this one? Well, remember in the last video, I said if you see an equation x equals k, that's going to be a vertical line that goes through the number k on the x-axis. So x equals 3 is a vertical line that goes through 3 on the x-axis. Where do you think all the points are where x is less than or equal to 3? Well, the vertical line is the place where all the points are such that x equals to 3. And if you go left of that, that's all the points where the x is less than 3. Okay, so you want, for this one, you want the vertical line 3, and you want all the points to the left of it. Think about this point right here. What's that point? That's 0 for x, 1 for y. Is the x coordinate of that point less than or equal to 3? Yeah, so it's in our answers, in the shaded part. Okay? All right, now that's the thinking for graphing these individually. In the system, meaning two inequalities, two or more inequalities that are considered together, I would graph each of these and I would see what their overlap is. So imagine if you had this graph and you had this one, okay? And you figured out where they intersected each other and where the overlap of the shading would be. That's the graph of the system, okay? I'm talking about that because we're headed to like needing to graph possibly 4 or more equations or inequalities and figure out where their overlap is, okay? All right, so let's see. That is what the overlap of these two are. One thing that I don't have here that I want to talk about is where this intersection is, okay? How would you figure out, if you believe that, yes, if you plot this line together with that one, they will intersect somewhere. And they're not parallel, so they're going to intersect. How do you figure out where they intersect? Okay, what's the intersection of 3x plus y is equal to 3 and x is equal to 3? Those are these two lines. How do you figure that out? So in the last video, I included my last example. I said, how do you figure out where two lines intersect? You can set them equal to each other. Y is x minus 3. Y is 25 minus 5/3 x. You want to know where those lines intersect? Take their equations and set them equal to each other. But this one will be a little bit different because they're not both of the form y. It's simpler than that, in fact. So think about it. If I wanted to figure out where these lines intersect, the second one says that I just happen to know that x is 3. So I could use that information and put it into the other equation. All right? So in math, if we know something, we use that to find out further things, okay? So look, I know x is 3 by the second equation. I'll put 3 in for x in the first one, and I'll figure out what the y is. You see, right there. Okay, and that will give me the point of intersection. So I'll get 9 plus y is equal to 3, and if I solve further, subtract 9 from both sides, I'll get negative 6. So the point of intersection is 3 for x and negative 6 for y. Okay? All right, so that one is a little different than the example I used for the point of intersection in my first video, but if it's like this, do it this way. If it's like this, if one of your equations just tells you what x or y is, then use that in the other equation, okay? All right, so that's how you graph inequalities. Now, obviously, it'll be more complicated to graph 4 or 5 of them together, right? But it'd just be that it's more work. Like you can graph any one of these by itself, and all that you're looking at here is their overlap. Now, here I'm doing this like kind of assuming that all you're using is paper, okay? Like no fancy calculator or anything like that. Of course you can use a calculator. In my first video I made, I was kind of going about it like, how would you graph a line if you had no other way to do it, okay? You could just plot any 2 points, make a table, plot any 2 points, all right? You could do that. But we do have graphing calculators, and it's fine if you use that too. I hope through the whole discussion, if we use a graphing calculator, we have a better idea what we're looking at when we do use one. So let's do like this. Here's a graphing calculator that I use sometimes, okay, at desmos.com. And like, I don't know, let's say like that I wanted this one, okay? So I'll type in 3x plus y equals 3. Okay, like that. And what it's giving me is the line that you see right here. Okay? In fact, it's using the same 2 points highlighted that I originally had. What if it was an inequality? What if it was 3x plus y greater than 3, kind of like I have right here? See how I put the dashed line and I drew a solid one? Well, that's because I put the greater than. If I'd put greater than or equal to, it would draw a solid line, but look what part of it it shaded. It shaded the region above the line. All right, so we can do that. And we could do more than one together. Like, what was the other one? X is equal to 3 or x is less than or equal to 3. So I can do like this, and now it's drawn both of them together, okay? And I could tell, like, with one being in red, I guess, and the other being in blue, that their overlap is this wedge-shaped region that you see here, okay? All right, so now you've got several tools available to you. You can graph these things, whether it's an inequality or an equation, with just paper and pencil if you want to. You can plot the points and do it that way. Or you could, if you wanted to, if you had access to this kind of thing, you could use a graphing calculator of some kind, either a handheld one or this one which I have on the internet. One more thing, the overlap, if you have a system, is called the feasible region, and that's a term that you'll hear as we go a little further at some point and talk about linear programming. Because remember, everything I'm telling you in these basic videos about lines, the graph of lines, inequalities, their graphs, it's all just for me to work up to talking about linear programming at some point.